This video here, we're going to construct an octagon given its diameter or point-to-point measure. All right. So first up here, let's just draw a 3-inch octagon. So I'm going to measure from 4 to 7. That's my point-to-point measure. Right, so let's say a 3-inch diameter or a 3-inch point-to-point on the octagon. Remember, an octagon is an 8-sided shape, and we are constructing regular polygons, which means it's an 8-sided shape with all sides and angles equal. So to begin this, first thing we need to do is we need to draw our circle. All regular polygons are inscribed inside a circle. It just depends on the number of sides that you want to fit inside that circle, which creates the polygon that you want to draw. So just to find center of this, I'll just quickly put an arc above and below. Right. Now I can connect through those 2 points. Which now gives me a perpendicular right in the center, at which point here I can circumscribe my circle. So using that midpoint as the radius. Again, before I draw the circle, I always just check to make sure that my geometry was okay. I'm pretty pleased with that. All right, so now I've drawn my circle about my 3-inch line. So now I'm going to create my octagon with point-to-point measures. Well, an octagon, basically what we want to try and figure out is the apex angles inside an octagon. So an octagon has 8 sides, right? That means that it is made up of 8 triangles. Right? And each of those 8 triangles, sorry, I'm writing off the screen there. I didn't realize. Let me just repeat that. So triangle, or the octagon, has 8 sides, which means that the octagon is also made up of 8 triangles. And each of those triangles has an apex angle. So in this case, the apex angle would be our 360 degrees divided by 8. Right? So if we figure that out there, we know that each apex angle is 45 degrees. So this is made up of 8 triangles, and each of those triangles are going to have an apex angle of 45 degrees, which adds up to our 360. So basically what that means is I got to pick one of these quadrants and find 45, right? Once I find that for 45 point, that will give me the side length up to where that 45 intersects with the circumference of the circle. Then I can draw in that segment there, or the chord, sorry, which would be the side length of my octagon. So pretty straightforward. I just set my compass up. And now for this, I could use the same radius and then just use these 2 points on the outside. In fact, why don't I just do that? So I'll just pick the 2 points where the circle intersects. Didn't quite extend that one far enough, but that's okay. And there we go. So now what I can do is I can connect this out. Now again, once you get this point, you have choices. I'm just going to draw that right in there just so you see it going through the bisector, which now creates 2 sectors, which are 45 degrees. So this angle right here is now 45 degrees, and so is this one. So basically what I want to do is I want to transfer this line around the circle. I could just continue this straight down here, which would find the bisector down here as well. Right? It would just be the same line that continues through to slice this one up into 2 45-degree apex angle triangles. And I could also then take this side here and bisect this very deep, which would give me 45 degrees. But I don't need to do that if I don't need to do that. because, as I mentioned, once you have this bisector here, this chord length, meaning the length from this point here to this point here, that chord length is the radius, or sorry, the length of my sides. So once I have that length, all I have to do is now just transfer that to the other two quadrants. So transfer it to each of those, and that now gives me my octagon. So at this point here, all I have to do is just connect all the points on the circle. And each one will be equal. So I just transfer that 45-degree angle on that radius. Right. But again, there's lots of different ways that you could have kind of found out these points at this point, but we don't need to worry about how we get there, as long as we get there a way that we understand it. And for me, just drawing in those same angles, basically copying that side length that I have here, just by copying that down to each of these points, that gives me all the sides of my octagon, which makes it nice and simple to solve out. And then now I have constructed an octagon very simply with all sides equal. Now I'm just going to talk about this octagon real quick. So of course, within this octagon, I can look at one triangle here, and within this triangle we obviously have the apex angle, which is 45 degrees, because all of those are 45 degrees. And then of course we have, let's just draw this over here. This here would be the internal angle A. Well, because our apex angle is 45 degrees, I'm just going to switch color. That doesn't seem to be showing up that clearly. So our internal angle in this case would be 180 degrees, right? 180 degrees, which is our internal angle. And then to find the miter angle, which would be this angle right here, or both of this case, this angle here and this angle here, that would be our B, or our miter angle. To solve that, I take 189 minus the apex angle, which is 45 degrees, right? That leaves me with 135 degrees split between these two miter angles, because that's now A, which is the two miter angles together, give me 135. So if I take 135 now, and I split that in two, that's going to give me my two miter angles. So 135 degrees divided by 2 means that that miter angle there is 67.5 or 67.5 degrees. Okay. Now, if I wanted to cut some fascia boards to go around the outsides of this, remember I would want to be left with that miter angle on the piece, right? So I'd have to cut the balance off of this off of 90. That would be my actual miter saw setting that I would set the miter saw angle up to cut any fascia boards or trim or any pieces that would form and make a octagon. So my saw setting would be my 90 degrees minus my 67.5 degrees, which would equal 22.5 degrees. That would be my miter saw setting to cut any adjoining angles to construct an octagon. And that concludes the octagon.